Welcome to MRL. In this learning session, we'll learn the exercises of end of chapter polynomials chapter of Ganita Manjari 9th standard CBSE textbook. In the first part, we have learned 8 of the examples of end of chapter exercises, and in this is the second part of the study of solutions of end of chapter exercises of the Ganita Manjari 9th standard textbook. Now in this, the 9th example, we have that we have been given here work done is equal to force into distance. It means we know the definition of work done. Work done can be measured by taking the product of the force and the displacement in the direction of the force. Now we have to establish a linear relationship between them, and the linear relationship is the work is equal to Fd for the displacement for a given force. The work done is equal to F into D for a given force. Therefore W is equal to Fd is the linear relationship between the work and the displacement for a given force. Now if the force is 3 units, then W is equal to 3D. That is again a linear relationship when the force is 3 units. Now if D is equal to 2, if the displacement is 2 units, then work done is equal to 3 into D, that is 3 into 2, therefore 6 units here. So although we know the unit of work, but still since it is mentioned as units, let us also mention here it as 6 units. Now we are required to draw the graph of W is equal to 3D and verify it whether the what we have got 6 units is correct or not. 6 units, let us see what is the graph first. Now if you look at the graph, if you look at the graph here, now the graph is a straight line graph. The graph is a straight line graph. I have taken the displacement in x-axis and the work done along y-axis. Now for 2 units of displacement, if I draw a perpendicular here, then I get the 6 units of work done. So the 6 units of work is done for a displacement of 2 units when the force is 3 units. Please understand here, this is a graph drawn for W is equal to 3D. I have found out the ordered pairs here. For D is 0, W is 0. For D1, W is 3. For D2, W is 6. For D3, W is 9. With these coordinates, I have drawn this graph. So therefore, when force is 3 units, the work done is 6 units, very clearly visible and indicated in the graph. So that is a straight line graph which we have got, and it is 100% true and correct. So please remember that. Okay, now coming to the next example, that is example number 10. We have been given a polynomial p of x is equal to ax plus b. The graph passes through 2 different coordinate points here, x coordinate and y coordinate, x coordinate and y, so I can call it as x1 y1 and x2 y2. Now we have to find out the polynomial p of x. Now to find the polynomial p of x here, we have to know the values of a and b, and to know the values of a and b, we require 2 equations. Because there are 2 unknowns here, we have required 2 equations. So let us frame the 2 equations first. Now one point, that is x1 y1, through which the line passes is 1 phi. So now we are being given the equation y is equal to x plus b, that is a linear relationship. Now when y is phi, then x is 1, therefore phi is equal to a into 1 plus b, therefore a plus b is equal to phi is the first equation. And also the line passes through 311. When 11, that is when y is 11, x is 3, and we get a into 3 plus b, that is 3a plus b is equal to 11, that is the second equation. So we have got 2 equations here in a and b. Now let us solve these 2 equations. A plus b is equal to 5, 3a plus b is equal to 11. And now subtracting, I get a minus 3 is minus 2a, and 5 minus 11 is minus 6, bb will get cancelled there. A is equal to 6 by 2, a is equal to 3. Once I know the value of a, then I can put the value of a in one of the equations there and get the value of b, and I have got the value of b as 2. P of x is equal to ax plus b, so p of x is equal to 3x plus 2. So if I draw this graph, definitely the line will have a slope of 3 and the intercept of the y-intercept as 2, and that is 100% true. Okay, so we can even draw this graph. So many graphs we have already drawn, and this is a very simple verification by drawing the graph. So let us understand that. Now to find the coordinates where px cuts the x-axis and y-axis, this is very important, and this is the second part of the same example. Now we are given y is equal to ax plus b, so y is equal to 3x plus 2, y is equal to 3x plus 2. Okay, y is equal to 3x plus 2, that is we have found out. Now if y is equal to 0, then I'll get x is equal to minus 2 by 3. So therefore when y is equal to 0, then x is equal to minus 2 by 3. Then one more thing is, if x is equal to 0, then I get y is equal to 2. So I have got the coordinates of y and also x here. So therefore the graph of px cuts the x-axis at minus 2 by 3, 0, and y-axis at 0 and 2, because I have got the value of x here and the value of y, and when it cuts the x-axis, definitely y will be 0 and x coordinate is minus 2 by 3, and when it cuts the y-axis, then x will be 0 and the coordinate of y is 2, and therefore the coordinates are minus 2 by 3 and 0 and 0 and 2, and we can verify drawing the graph very easily. So let us learn that. Now this is the graph of y is equal to 3x plus 2. Let us understand this graph and also the characteristics of the linear polynomial, linear equation y is equal to 3x plus 2. Now finding out the coordinates of y is equal to 3x plus 2, I found out 3 coordinates here, and having located the coordinates, I have drawn the graph. The graph is a straight line graph because it's a linear equation, and if a is the slope is 3, that is it is positive a or positive slope, and therefore the line is inclined towards the right, and also the y-intercept is 2, and therefore the graph is cutting, the line is cutting the y-axis at 2. So that confirms the value of a and b in the linear equation y is equal to 3x plus 2, and that is verified. Now also the graph cuts the x-axis at minus 2 by 3, 0, and also it cuts the y-axis at 0, 2. So that again confirms or verifies the line of the linear equation y is equal to 3x plus 2, which we wanted to verify. So that is a verification of the given linear equation y is equal to 3x plus 2. Okay, so that is how it is verified. Now example number 11. Now what is given to us is that p of x is equal to ax plus b, q of x is equal to cx plus d, and also we have some information given that p0 is 5, px minus qx cuts the x-axis at 3, 0, px plus qx is equal to 6x plus 4 for all x, and we have to find now the polynomials p of x and q of x. We have to find these two polynomials. Now to find these two polynomials, we have to find the values of a, b, c and d. That means there are 4 unknowns here. We have to find these 4 values to get p of x and q of x. Let us see how to do that. Now p of 0 is equal to 5, it is given to us. So take p of x is equal to x plus b and put x as 5 there. That means we have to find out p of 0 is equal to 5. So wherever x is there, put 0, we get a into 0 plus b is equal to 5, therefore we have got b is equal to 5. So we have got the value of b there. Now let us take the third equation, that is px plus qx is equal to 6x plus 4. Now opening the putting the value of p of x is equal to ax plus b and qx is equal to cx plus d, and rearranging them, we get a plus c of x plus b plus d is equal to cx plus 4. By inspection and comparing LHS and RHS, we find that a plus c is equal to 6 and b plus d is equal to 4. Now we have got two new equations here, but from b plus d is equal to 4, we have b as 5 already, and plus d is equal to 4, therefore we have got the value of d as minus 1. So we have got the value of d and the value of b. Now let us take the again second equation, px minus qx, which cuts the x-axis at 3, 0. It means that y is 0 when x is 3, and therefore putting the value of y is equal to 0, p3 minus q3 becomes a into 3, because x is 3, and plus b minus c into 3 minus d. That means I have put here 3, so it will become 3a plus b, and here I have put as x as again 3, I get minus 3c minus d. That means 3a plus b is 5, we have got the value of b here, 3a plus 5 minus 3c minus d, and that is 3a plus 5 minus 3c, but we know that d is minus 1, so putting the value of d here as minus 1, I get minus of minus becomes plus 1, and 3a minus 3c plus 5 plus 1 becomes plus 6. Now 3a minus 3c is equal to minus 6, taking 6 that side, so 3 of a minus c is equal to minus 6, a minus c is equal to minus 6 by 3, and we have a minus c is equal to minus 2. So we have got the equation a minus c is equal to minus 2, but also we have a plus c is equal to 6, so we can simplify the equation 3 and equation 6, that is we can solve equation 3 and equation 6, that is a plus c is equal to 6 and a minus c is equal to minus 2, 2a is equal to 4, a is equal to 4 by 2 and a is equal to 2. So now we have the values of a, b, then D, and also we can find out the value of C. So we have got all the 4 values, that is A is equal to 2, B is equal to 5, and C is equal to 4. C is equal to 4 and D is equal to minus 1. So we have got the C value here because A is 2, that means 6 minus 2 becomes 4. So C value also we have got. So we have got all the 4 values. Now putting these values in the polynomial, the required polynomials are P of x is equal to 2x plus 5 and qx is equal to 4x plus or minus 1, that is qx is equal to 4x minus 1. So these values of a, b, c, d we have substituted in the polynomial p of x, and in the polynomial q of x we get p of x is equal to 2x plus 5 and q of x is equal to 4x minus 1. So please understand this and learn how to solve this, although it is lengthy, but still we can solve them. Okay. Now the 12th example is we have hexagonal patterns given here, where they are made by using matchsticks. Now the first pentagon, hexagon, is made of 6 sticks, 6 matchsticks. Now the second stage I have not drawn here, I have drawn straight away stage 3, but let us understand stage 2 here. The first hexagon has got 6 sticks, whereas the second hexagon has 1, 2, 3, 4, 5 sticks. Third hexagon 1, 2, 3, 4, 5. That means all subsequent hexagons require only 5 sticks to be to form that hexagon. So now we have to find out the number of sticks required for the first stage, second stage, third stage. So first stage we require 6 matchsticks, second stage we require 6 plus 5, that is 11 matchsticks, and third stage we require 6 plus 5 plus 5, and that is 16 matchsticks. Now like that, since it is forming a linear pattern here, now what will be the number of matchsticks required for n stage? So m of n is equal to, the number of matchsticks of n is equal to 6 plus 5 into n minus 1, or it is m of n is equal to 5n plus 1. So we can verify this if you want. Now if I take n as 1 here, so n as 1 here, 5 into 1 is 5, 5 plus 1 is 6 matchsticks. If I take 2 here, 5 into 2 is 10, 10 plus 1 is 11 matchsticks for second stage, and 5 into 3 is 15 plus 1, 16 matchsticks for the third stage. So therefore n stage we will have 5n plus 1 matchsticks which are required. Now also in the second part we have to find out the matchsticks required for 15th stage. So let us use a relation there, that is linear pattern, that is linear relationship. M of n is equal to 6 plus 5 n minus 1. We want 15th stage, so use the 15th stage here. So it will be 5 into 15 plus 1, 75 plus 1. So 76 matchsticks are required to have 15 hexagons arranged by using the 76 matchsticks. Now the next is how many, if 200 matchsticks are used, then will it complete the hexagonal pattern? So let us understand that. So mn is 200, 5n plus 1 is the general form, and 5n is equal to 200 minus 1, that is 199, n is equal to 199 by 5. And you find that n is not a natural number, n is not a whole number, therefore it is a fraction there. So fraction, we cannot have a fractional matchsticks rather, so whole matchsticks are required. So n is not a whole matchstick, it is a fractional, therefore 200 matchsticks will not form a hexagonal pattern in incomplete. So please remember that. So that is what is the example. Now coming to the next example, we are given p of x is equal to ax plus b, q of x is equal to cx plus d. Now graph of px passes through the points 2, 3 and 6, 11 again. Graphs of qx passes through the point 4, minus 1, and graph of px is parallel to the graph of qx. So this much of information is given to us. We have to understand these information and try to answer the questions asked. Now what is the first question? We have to find the polynomials p of x and q of x. That means we have to know the values of a, b, c and d, then only we can write these polynomials, and let us see how we can do that. Now let us take the first polynomial px of p of x is equal to x plus b. Now that passes through 2, 3, therefore y is 3, so 3 is equal to 2a plus b, because a is 2, so that is first equation. Now the same line passes through 6, 11 also, so it is 11 is y, and 6a, that is x is 6, so 6a plus b. So we got two equations here. From the two equations I will get a and b. So solving to 1 and 2 we get 2a plus b equal to 3, 6a plus b is equal to 11, minus 4a is equal to minus 8, so a is equal to 8 by 4, or a is equal to 2. Put the value of a is equal to 2 in one of the equations, then 2a plus b is equal to 3, 2 into 2 is 4 plus b is equal to 3, so we got b is equal to minus 1, so a is equal to 2 and b is equal to minus 1, we have got the value. So a is equal to 2 and b is equal to minus 1, therefore we have got the p of x as 2x minus 1. So for the first polynomial is we have obtained the first polynomial as 2x minus 1. And p of x, the slope of p of x is a, that means a is 2 here, so the slope of p of x is 2. But we have been given that the graph px and qx are parallel to each other, therefore the slope of qx also is 2 because they are parallel. When the lines are parallel, the slopes are same, and therefore qx is equal to 2. If qx is equal to 2, it means that the value of c is already known to us, that is, it is 2. Now, having known c as 2, we also know that the graph, that is qx is equal to x, that qx is 2x plus d, this passes through a point, and that is point is 4 minus 1. That means we know that y is 4 and then x is minus 1. So substituting the values, we get y is minus 1, it is 4c plus d, c is 2, so we get d as minus 9. Therefore we now know that c is 2 and d is minus 9, therefore q of x is equal to 2x minus 9. So we have found out both the polynomials p of x and q of x. In the second part, we have to find the coordinates of the point where the two lines cut x-axis or meet x-axis. Now when they meet x-axis, that means but natural y coordinate is 0, so y is 0. So let us put y is equal to 0 there. So y is equal to 2x minus 1, 0 is equal to x minus 1, 2x is equal to 1 and x is equal to half, and therefore the p of x is equal to 2x minus 1, the line cuts the x-axis at half and 0, and same here also, that is in qx is equal to 2x plus 2x minus 9, y is 0, y is equal to 0 is equal to x minus 9, 2x is equal to 9 and x is equal to 9 by 2. That means the graph or the graph of qx is equal to x minus 9 cuts the x-axis at 9 by 2 and 0, the x coordinate is 9 by 2 and the y coordinate is 0, and that is how we can find out, or we have found out, the coordinates of the points where the line cuts the x-axis. Please understand and learn this. Now coming to the next example, we are given a general function here, f of x is equal to ax plus a, where a is greater than 0. Now we have to find out what are the linear functions of this form, and rather what are the important linear functions which are common in this case, or which they have in common. That means this is a general form, therefore we can have different lines there, and we have to identify what are the common characteristics those lines will have. F of x is equal to x plus a, it is given, and a is greater than 0. Now the common properties what we can find out or have are, the first one is the slope, second one is the y-intercept, and the third one is the x-intercept. So let us go for the slope first. The slope in this case, the slope is a, and a is greater than 0. If a is greater than 0 but natural, the lines will have a positive slope and are inclined towards the right. So all the lines which we get from this function are having positive slope, and therefore they incline towards the right and the slope is positive. Now come to the y-intercept. Again y, that is b is a here. That means we have, if I put x is equal to 0, then y is equal to a, but natural. So the y-intercepts are, the y-intercept is 0 and a. So the lines have the y-intercept as a, and a is greater than 0. Therefore the y-intercepts are, or all of them are above the origin. So we have the y-intercept as a, and they are all above the origin because a is positive. Now the x-intercept means we have to put y is equal to 0. If I put y is equal to 0, I get x as minus a by a, that is x equal to minus 1. That means every line cuts the x-axis at minus 1 and 0 because x coordinate is minus 1 and the y coordinate is 0. So that is how we find the values of these coordinates there. That completes the study of the exercises of polynomials chapter of Ganita Manjari 9th standard CBSE textbook. Now please learn all the examples, the basics of this chapter. Apply those basics what you have learned to solve these examples. Methods of solving should be understood, and please note down them in a book for your future reference. Okay, so that concludes this polynomials chapter of your textbook. Okay, thank you.